Hello and welcome back to another video. In this one we'll be taking the last topic of Laplace inverse, and that is applications of Laplace. So the applications of Laplace format is as follows. For example, if we have y double dash plus pi squared y is equal to 0, and you are also given within this question is boundary conditions. So y of 0 is equal to 1 and y dash of 0 is equal to 0. Now please keep these written in your notebook while solving these types of questions, as they are the key to the solution. So we take the Laplace transform of both sides of the differential equation. So the Laplace of y double dash is s squared y of s. So we substitute y dash with s squared y of s minus y of 0 s minus y dash of s. Sorry, y dash of 0 plus pi squared, and we substitute the value of y, which is y of s, and that is equal to 0, since the Laplace of 0 is 0 divided by s, which is just equals 0. Now we have to substitute the values of the boundary conditions in our equation. So we have y squared y of s minus 1 s minus 0 plus pi squared y of s is equal to 0. Now we group the y of s's together, so we have y of s multiplied by s squared plus pi squared, because both of these terms have y of s multiplied by them, minus s is equal to 0. Now we take the s and move it to the other side, so we have s squared plus pi squared y of s is equal to s. Now we divide by s squared plus pi squared, which would give us y of s is equal to s divided by s squared plus pi squared. Now to find the solution for this question, we take the Laplace inverse of both sides. So the Laplace inverse of y of s is equal to y, and the Laplace inverse for this fraction is a direct transformations of Laplace. If you are familiar with the topic, you'd find that s divided by s squared plus pi squared is very similar to cosine of at, since the Laplace of cosine at is equal to s divided by s squared plus a squared, and we have a as in a is equal to pi, so a squared is equal to pi squared. Therefore, the solution for this differential equation is cosine pi t, and that's the final answer. For example, let's take another one. Let's take another differential equation and see where it goes. For example, if we have y double dash plus 2y dash minus 8y is equal to 0, and the y of 0 is equal to 1, and the y dash of 0 is equal to 8. now we do the same thing, so we take the Laplace of both sides and replace the values of y double dash and y dash and y. So with y dash is we have s squared y of s minus y of 0 s minus y dash of 0 plus 2 s y of s y of s y of 0 plus minus 8y is equal to 0. Now we substitute the value of the boundary conditions in our equation. So we have s squared y of s minus 1s minus 8 plus 2 multiplied by sy of s minus 1 minus 8y is equal to 0 of s, obviously, y of s. So we group the y of s's together, so we have y of s is s squared plus 2s, because we have 2 multiplied by sy of s, so it's 2s, minus we have the negative 8 here, negative 8, minus s minus 10. So we have the following, and is equal to 0, obviously. So we have y of s squared plus 2s minus 8, and it's equal to s plus 10. Now we divide by the s squared plus 2s minus 8, so we have y of s is s plus 10 and s squared plus 2s minus 8. Now we can split the denominator into two different brackets, so we have 1 and 2, plus multiplied by a positive multiplied by a positive is a positive multiplied by a negative is a negative. To get s squared, we get s and s. To get 8, we have to multiply 4 and 2. So if we multiply these two brackets, so we have s squared negative 2s plus 4s negative 8. So we have s squared plus 2s negative 8. We get the same as the denominator. So our fraction becomes s plus 10 divided by s plus 4 divided by s minus 2 multiplied by s minus 2. Now this is not a normal Laplace transform fraction. What we have to do is use partial fractions. So we say a divided by s plus 4 plus b divided by s minus 2. Now we multiply both sides by the denominator of the left hand side. So we have the following: s plus 10 is equal to a multiplied by s minus 2 plus b multiplied by s plus 4. Now by distributing the a's and b's, so we have a as minus 2a plus bs plus 4b. Now we create two formulas. So we have as plus 4 plus bs. So as plus bs is equal to s. Divide by s is a plus b is equal to 1. Now we have negative 2a plus 4b is equal to 10. Divide by, or let's just take the value of a. So if a is equal to 1 minus b, if we substitute the value of a in this equation, let me just make a little more space. If we substitute the value of a in this equation, we have negative 2 multiplied by 1 minus b plus 4b is equal to 10. So we have positive b, positive 2b plus 4b is equal to 10. 6b is equal to 12, and b is equal to 2, because 12 divided by 6 is 2. So we take the value of b and put it into this equation. So we get a is equal to negative 1. Now we substitute the values back into the equation. So we have a is equal to negative 1 divided by s plus 4 plus b divided by s minus 2. B is equal to 2. Now we take the Laplace inverse for both of these equations. So we have negative 1 divided by s plus 4. So it is it's a direct Laplace inverse of exponential negative 4t, because exponential at is equal to 1 divided by negative exponential negative 4t, because exponential is 1 divided by s minus a. To make this 4a plus here, we have to put the 4 as negative 4, because negative 4 and a negative is equal to positive. And the other side is equal to, let's get rid of this to make it more uniform. So we have the Laplace inverse of negative 1 divided by s plus 4 is negative exponential negative 4t plus 2 multiplied by exponential 2t, and that is the final answer. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.